So we were discussing this signal flow graph, and I uh, explained what is source node, what is sink node, what is chain node, what is forward path. So this forward path is important. Like now, these are the nodes x0, x1, x2, x3, x4, and x5. So x0 is the source node, x5 is the sink node, and then remaining are the chain nodes. So forward path is now this is. So you have to identify how many paths are there. So now this is one forward path. Then these are the x0, x1, x3, x4, second forward, then third and fourth. Then feedback loop. The skin is visible, no?
Yes, sir.
So what is so other than these four? Is there any other forward path? This is very important for solving the problems. Identification of the forward path. Like I showed you, x0. This is one straight away. X0, x1, x2, then x3, x4, and x5. Then second forward path is x0, then x1, then like this x3, then like from here like this, and then like this. Then third forward path will be x0, x1, x2, then x3, and like this. Then fourth is x0, x1, x2, and then x5. So what about this? What is this fourth forward path? Can you tell me? x0, x1, x2, and then directly it is x5. So is it correct this? I'll zoom it. And here it is written no node is to be traced twice. So I'm asking what is this fourth forward path is? Can you tell me, Hardik?
Sir, we have taken X4 in the second thing.
x0, x1, then
X4
x2,
we have taken.
x2, and then
X2. X4 we have taken, correct? Then X2 will be cancelled and X5.
no. So what is this fourth forward path is? Does it exist or it doesn't exist?
Sir, it exists, but as
What is
we
that path? Uh, so x0, x1, x2, and then x3, and then from x3 it is going like this, x5. Okay, don't bother. This is actually wrong here. Now let's go for feedback loop. Hmm? Yeah, feedback loop is now x2, x3, x4, x2, then x3, then x4, and again x2. So this is feedback loop. Then feedback loop consisting of only one node, that is called as the self loop. So T3 at x3, that is this. So this is called as the self loop. So see, Whether you are clear or you have doubt.
No doubt, sir.
Hmm. ठीक है. Now, how to find out the path gain? So now, suppose if this is the path, so path gain is found out by this relation. One that is for the first one, then T12, T23. So that will be given T12. This is one which is given in the beginning, and this is your T12, and this is T23, T34, and T45, and so on. Okay, so you have to just multiply in order to find out the path gain. And these are the properties of signal flow graph. Value of variable represented by any mode is sum of the signals entering the node. So like x2 is equal to what are entering there, t12 into x1 and plus t42 into x4, x2, that is this. So what is entering here, t12 into x1, and what is entering here, this t42, this t42 into x4, that is this x4 into t42, x1 into t12. That is what is explained here. So suppose now how to obtain the signal flow graph. Now these are the system equations are given, V1, V2, V3, V naught. This is your output is V naught or VO, and input is say V1 or VI. This is your input, this is your output, and these are the values of the system variable. That is, here you have, so this is VI, this is V1, V2, V3, and VO. VI for the input and VO for the output. Yeah. Now just look at this and see whether you can draw this signal flow graph or not from this given equation. So V1 is equal to 2 Vi plus 3 V2. That is this. This is the gain values for each and every node. So 2 Vi, this is incoming, and you have this is 3 which is incoming here from V2. Now V2 is equal to 4 V1 plus 5 V3. So V3 is this, and gain for this is 5 plus 2 V2. So you have to just go on. First you have to write Vi, ऐसा नोड दिखाने का Vi, V1, V2, V3 and VO. Okay. Then V3 is equal to 5 V2 plus VO. That is this 5 V3 is this, and VO is this. This is the feedback, and this is the 5 V2, and then VO is equal to 6 V3. Okay, so like this question will be asked, and of course you have to find out. Sorry, I forgot. And of course you have to uh, find out the gain. So V1, V2, V3. Hello, is this clear? This
Yes, sir.
uh, from these equations. So these are the given system equation, and from this you are drawn this. You have to draw this. Okay. Now there is something called the Mason's gain formula, which is used to find out the transfer function. So this is the transfer function. So that is given by this relation. Transfer function is equal to, it is summation of this formula, not this summation of tk delta k upon delta. So just concentrate on this. Summation of tk delta k upon delta. So now tk is nothing but gain of kth forward path. Tk is nothing but gain of kth forward path. That is, suppose if I write here T1, so that will be gain of first forward path. If it is T2, it will be gain of second forward path. We have seen first forward path, second forward path, third, fourth. So, and we have seen also how to calculate the gains. Then K is nothing but number of forward paths. In earlier example, there were 4 forward paths. So you will have 4 gains, T1, T2, T3, T4. So T3 means gain of third forward path. Delta is nothing but the determinant, the complete system determinant. And how to find out the delta? This is slightly complicated. Delta is how to calculate the system determinant. So that is equal to 1 minus inside the bracket summation of all individual feedback loops, including self loops, plus gain product of all possible combination of two non-touching loops minus summation of gain product of all possible combination of three non-touching loops. And delta k is nothing but this only, that is system determinant, but you have to find out like delta 1, delta 2, delta 3. So it is the value of this delta by eliminating all loop gains which are touching to the kth forward loop. So just concentrate on this. Slowly you will understand when you take example. Just try to understand this. Just look at the formula carefully. So let us take this example. So now summation of Tk delta k. So now first we'll identify how many paths are there in this example. So there are two forward paths. One is like this and another is like this. One is like this. Arrow देखो. This and another is like this. ये जो है this is forming a feedback loop. This and this is again forming a feedback loop. So number of forward paths is 2. So k is equal to 2. So that means you will have to find out two gains, T1 and T2. So T1 is nothing but gain of first forward path and T2 is nothing but gain of second forward path. So first forward path is like this. So उसका gain will be T1 is equal to G1 then G3. So this is G1 then this is G3. और थोड़ा zoom करता हूँ. G1, G3, G4, G5 and G6. Okay, so this is the gain of first forward path. Then T2, that is G1, then G2 and then G6. This is the gain of the second forward path. Now what are the loops? Feedback loop or self loop. So now look, this is L1. So this is one loop. This is one loop. That is G4 and H1. The gain for this is G4 and the gain for this is minus H1. So L1 is nothing but gain of L1 is nothing but G4 H1. So it is shown like this. Now loop number 2. Loop number 2 is like this. Second feedback loop like this. This is a loop number 2. So that is nothing but G3, G4, G5 and then H2. And since it is feedback, it will be minus H2. G3, G4, G5 and minus H2. So L2 will be minus G3, G4, G5. The gain of this loop 2 will be G3, G4, G5 and then H2. Then L3, L3 is this. This is your L3. So similarly, L3 will be, that is this gain G2 into H2. So this is what is your L3, that is feedback loop. So G2 into H2 minus. So it has been shown separately. See one loop, this loop L1 is this, then L2 is this, and then L3 is like this. Please try to understand these loops. So slowly it will be confusing. So now you have to identify which are touching loops and which are non-touching loops. Which are touching loops and which are non-touching loops. So L1, that is this, and L2, that is this. So they are touching. See, look at this. This is L1 and this is L2. So they are touching over here, ये portion में, this. Similarly, find out some more touching loops. So L2, look at this. L2 and L3, are they touching? L2. L2 is this and L3 is this. So they are touching here. Now non-touching loops. So this L1 and this L3, they are absolutely non-touching. So that means there are two touching loops and one non-touching loop. Okay, so now system determinant. So how to find out the system determinant? So system determinant is found out by this relation: 1 minus sum of all loops. Here it is sum and here it is product. Sum of the all the loops plus product of the non-touching loops. 1 minus sum of all loops plus product of two non-touching loops. Remember this. This is slightly confusing. Here 1 minus summation or sum of all individual feedback loops, and it will include self loop also, plus product of all possible combination of two non-touching loops, minus gain product of all possible combination of three, like that it is. Okay, so how many feedback loops are there? L1, L2 and L3. So you have to sum. So add karo L1, L2, L3 plus now product, that is L1 into L3. L1 into L3. Okay. See, these are the, see, this L1 and this L3. These are the non-touching loops. So you got delta here. Now you have to find out delta 1. So how to find out the delta 1 here? Value of above delta, that is this, by eliminating all loop gains which are touching to the first forward path. So delta 1, eliminate L1, L2, L3, delta 1. So touching to T1. So you have to see now which loops are touching to T1. So T1 is this, T1 is this, and T2 is this. So T1 ko your L1 is touching, your L2 is touching, and your L3 is also touching. So all the three loops are touching. So L1 0, L2 0, L3 0. Because you have to eliminate L1, L2, L3 as all are touching to T1. So you have to take these values as 0, which are touching to the, whichever loops are touching to the first forward part, delta 1, you have to take it as 0. So delta 1 is equal to 1 minus 0, 0, 0, 0 into 0. So 1. So delta 1 is equal to 1. Now delta 2. You have to find out now which are touching to second forward path. Second forward path is this. This is your second forward path. So L1 is not touching to second forward path. That is this. L1 is not touching to second forward path. L2. L2 is like this. This is your L2. This is your L2. So L2 is touching to the second forward path, and L3 is also touching to the second forward path. So value of L2 and L3 will be 0. L2 is equal to 0, L3 is equal to 0. Now substitute. So 1 minus this L2, L3 0, L1, and here L3 is 0. So this also will become 0. So that means you will have 1 minus L1. So now substitute in Mason's gain formula. That is summation of, Mason's gain formula is nothing but this, summation of Tk delta k upon delta. So It will be T1 delta 1 plus T2 delta 2 upon delta. Okay. Now let us find out delta. So delta is this, and your delta summation, that is numerator, will be T1 delta 1 plus T. Now you substitute the values. What is T1? So T1 we got this G1, G3, G4, G5, G6. And what is L1? So that you have to substitute. So G1, G2, G3, G4, G5, G6. And what is the value of delta 1? Delta 1 is 1. Similarly T2, G1, G2, G6. And what is the value of delta 2? So delta 2 is this 1 minus L1. And what is L1? L1 we have already found out, G4 minus G4 H1. So that you have to substitute here. And delta, where is your delta? Delta is this. Again you have to substitute here all L1, L2, L3. Whatever we have found out here, that you have to substitute. And then this is the transfer function. Okay, so you solve this example and upload it in the classroom. Okay, write down the Mason's formula properly, show that L1, L2, L3 properly, and upload it. We'll stop here because unless and until you get grip on this, because SFG is something new to you, so try to get a grip on this, then we'll proceed further. If you have any doubt, you please ask. Any doubt here?
Also.
Okay, ठीक है. We'll stop.